I want you guys to get a blank piece of paper and a dark, something that can write dark so it's easy to see in your webcam, because you're going to show me what you're creating here. And all right, so on this screen, I got an equation here. We're going to graph this together, but we're going to graph it in stages. This is actually the 8.2 lecture notes. It's the last question. And so, first of all, remind me what trig function is to cosecant related to?
Sine.
Right. So here's what we're going to do. What we're going to do is go in stages. First stage is think about it as 2 sine of x plus pi over 4 minus 1. And what I want you to do here is draw a box. And so on your box, you're going to have to communicate to me what is the start x, and there'll be a midline, and what is the end x, and then what is the max and the min. So you've got a y max and a y min. And so that's all I want is 1, 2, 3, 4 numbers and a box. All right, so you're not going to draw a graph. You're not going to put a wave in there. You're only going to draw a box. Is everybody understanding the direction so far?
Yes.
So this is going to be a step-by-step process. We're not doing the whole thing. Your job is to get one box. Now I'm going to put you in groups or pairs probably. Let's see, we'll have one group of 2, one group of 3. So I want you to talk with each other and take this sine equation and figure out amplitude, period, and phase shift, and figure out the box so that you guys can then take your box and stick it in the camera. All right, here comes the group. So you got an invitation to join your group, and I want you to get in your group and find amplitude, period, phase shift, and then draw a box. That's it, just draw a box. Okay, you guys can see my equation, and let's do a fast rundown. Stuff that was pretty straightforward. No, I didn't see problems out there. You were doing great. Amplitude was 2, and the period was 2 pi. The phase shift is negative c over b, but b is 1 and c is pi force. So I'm not going to do the steps here because you guys all found it. Negative pi force. And the vertical shift was negative 1. Now, the x-axis, the xy axis can kind of throw us off. So I'm going to show you a little cheat, and several of you picked up on the cheat. When you draw your box, don't worry about the x-axis. If you're just going to sketch, just draw the box. Now the x-axis is moved over a little bit, and you could put it in there if you want, but we don't really need to. We just need to find this midline. And then look at the top of the box. Now, I actually, for me though, I'm very visual, and so it throws me off if I do this. So I'm going to put in the x-axis. Sounds like somebody has a printer. That's a good thing to have. So let's see. Now, where is the x? Here's my x-axis up here. Where's the start of the box on the x-axis? What number am I starting with?
Negative pi fourths.
Right. And where is the top of the box?
One.
Right. So up here, I'm going to put my y number 1. And the amplitude is 2. So I went down 2 to -1. That's the midline. And then I went down -2, -3. There's the bottom of the box. So I clearly marked the amplitude and the period and then the phase shift. Now, I was really happy to see in past classes, a lot of students would say, oh, the period is 2. And so they would come over to the end and put 2 pi. And lots of students in my past classes would do that, but I don't think any of you guys did that, which was great. Because what's wrong with this logic? Why is the end not 2 pi?
Because it starts at negative pi fourths.
Exactly.
So over.
If we shift the front backwards, we're going to have to shift the end backwards. So we're going to have to minus pi fourths to really find the end. And so, as I recall, everybody had it correctly. Shift the end back. Okay, now we have to divide the box in half, and then these halves in half. And here's where it was a little tricky. But that's all I asked you to do. All I asked you to do was the top and the bottom, the beginning and the end. Now, this is not scaled so well. So if this is not quite half, I didn't draw a true halfway mark. It's a little too far over. Should be more, halfway is more about here, and halfway is more about there. So, I mean, it's not perfect, but this is like 1/4, 2/4, 3/4, 4/4, and I did a bad job. It's not really scaled well. So each of these divisions should be about the same. That's 1/4 of the box, 2/4, 3/4, and 4/4. So this distance on all 4 of these marks needs to be equidistant. Same distance, the same, the same, the same. This one is a little bit too skinny, but as long as we draw our wave in there quickly, we'll be all right. Now, if you got all of that, and you draw the right wave, you're going to get a B or B plus. But to get the A, I want you to be able to tell me these X numbers. We already have 2 of them, the beginning and the end. There's 3 more. What are these X numbers? For lack of a better way to describe them, those X numbers are based on a tick mark. First tick mark, second tick mark, third tick mark, and I need to know the value of that distance. Well, the whole box is 1 period. And we're dividing the box into 4 pieces. First piece, second piece, third piece, and fourth piece. So if we want these distances, we can do the tick mark, which is the period, divided in 4 subdivisions. And our problem has a period of 2 pi over 4. I'm going to leave it. It's 2 pi over 4. So this distance is 2 pi fourths, 2 pi fourths, 2 pi fourths, and 2 pi fourths. So each of these subdivisions is 2 pi fourths. So if I start at negative pi fourths and I add 2 pi fourths, what is the first tick mark?
5-fold.
Right. Now I'm going to do the second tick mark. Well, the distance of each tick mark is pi fourths. So if I go pi fourths plus 2 pi fourths, where am I now?
3.
5/4.
Great. And then 3 pi fourths plus the next tick mark is 5 pi fourths. Now, here's where the rubber meets the road. This is where I check everything. Because 5 pi fourths plus the tick mark should take me to the end. What's 5 pi fourths plus 2 pi fourths? 7 pi fourths. I've got perfect closure right to the end. So the box with the beginning and the end and top and bottom in the right wave, that's like a B or B plus. But if you put the box with the tick mark labels on the x-axis, that's going to put you into the A category. Okay, next. Let's do the wave. Now we started out looking for sine. And so let's do the sine wave together. The sine wave starts at the midline. And then from the midline, I go up. So at this quarter point, I'm going to be at the top. The next quarter point, I'm at the midline again. The third quarter point, I'm at the bottom. And now I'm back up to the midline. And I'm going to do the sine wave with a dotted line because I really don't want the sine wave. I want the cosecant ultimately. Okay, so I want you to get that in your box. Now I'm going to put you back in your groups, and what I want you to do next is I want you to draw not the sine. We've already drawn the sine. I want you to use the sine and draw the cosecant. And so make sure you can, so put your pictures in the camera so that people can see each other's graphs and really check to see if you're getting the same graphs, and if not, then talk about why is it different. Okay, so here you go. You're going to go back to your groups and share your pictures. Okay, everybody's back. I'm going to share something with you just to kind of wrap it up. That I think is a reasonably difficult graph, and you guys all worked your way through it piece by piece, and you were successful. So this is great. Good job. Let's do a wrap up of this, and I'm going to share with you. All right, so that was our ultimate objective, and we got there by a few simple strategies. We first figured out the sine wave. Let me make it in blue here. So we figured out the phase shift. That's not a good color for what I want to do. I'm going to try a different one. We figured out the box, and it was shifted back It's negative pi halves. And it started at 1, and the midline was at negative 1. And so the box went down, and it went down to negative 3. So we figured out the height of the box. And then we figured out the period of the box. It wasn't 2 pi because we had to shift back pi force. So we had to shift back pi force, shift pi force. Okay, so that was the end of the box. And the next thing we need to do is just, we got to find asymptotes. Because if we're going to graph the cosecant, it all hinges on asymptotes. And the asymptotes hinge on sine being 0. Because when sine of x equals 0, 1 over sine will be undefined. And so that's when cosecant is not going to work. So all we need to do is find when sine equals 0, and we've got asymptotes. So if we do a quick sketch of sine, we're going to take our box and cut it in half, cut those halves in halves, and then we can do a targets. Sine will hit here, up, down, down, and down, and we got our quick sketch. Now we don't really need the sine wave. All we really need is the zeros. And because sine is 0 right here, I got an asymptote on the sine because the sine hits the midline, and that's going to make my complicated equation have a 0 right there. I have another asymptote right here, and then I have another asymptote right here, and that's the work done. Because with those asymptotes, then I can do a quick sketch of the wave. And so this piece of sine here is going to get flipped up. And this piece of sine here is going to get flipped down. And we're all done. We made a quick sketch of a really complicated graph. So that was a good job. But it all hinged on the box. We needed to get that box going. And once we had the box, everything fell into place. All right, let's take a break. It's 10:30, 10:33. Let's come back at 10:43, and we'll practice a little bit more on secant and cosecant stuff. And then we're going to start 8.3 after that. All right, so I'll see you in 10 minutes.
I'm here.
All right, good. What I want to practice a little bit more with secant and cosecant. But this time I want to practice with Desmos. I mean, not with Desmos, with Newton. Okay. All right. So we're going to do the same thing, except we're going to do it in Newton. So we have an equation we're already given. It's 1/2 secant of x minus 3 pi fourths minus 1. Now, unfortunately, it's not very different than the equation we just did. So maybe I'll take a moment and do another one of these, but let's practice with this. So what's the game plan? Well, it's a little different strategy here because they've already graphed a normal secant. And our job is to transform the normal secant into this one here. So what do you see that we're going to have to transform? What do you think we should take care of first?
The midline.
Yeah, midline, vertical shape.
Okay, so I have a red dot, a blue dot, and a black dot. What do you think is the midline here? The red one or the blue one or the black one?
Maybe blue. Is it y equals something? It looks like.
Okay. Now, if I move the blue one, I'm moving the amplitude.
It's a red one.
Let's try the red one. Okay, red one is moving everything. Okay, so I'm going to
All right.
move it. I'm moving it. Where do I move the red one to?
Negative
One.
1.
Yeah, -1. Okay. Now, that's the midline, and that is the center point of the sine wave. Oh, actually, no, cosecant is cosine. Okay, so now, but is that the only movement I have to do is just down?
No.
To the right.
Negative 3 pi force is a right shift. So here is 2 pi force. Pi halves is 2 pi force. Here is 4 pi force. That's too far. So 3 pi force is right in the middle. It's only letting me move by pi force anyway. Okay, so now I've got my wave starting position for my box. What's the next adjustment we should do here?
Amplitude.
Amplitude, right? And so right now, what is the amplitude?
What half?
Yeah. Well, no, the amplitude is 1. And Alan, you're telling me what it should be, and you're correct. What it should be is a half. So instead of having an amplitude of 1, like I can start expanding or shrinking the amplitude. So right there, the amplitude is now half of what it should be. And so we took care of the amplitude, and we took care of the shift, the inside horizontal shift and the outside vertical shift. Anything else we need to take care of?
The period?
The period. Very good. What is the period?
2 pi.
2 pi. I'm almost thinking it would have been better to do the period before the shift.
The
Because
period's
now-
already right. Though.
I think you're correct, Carl. I think it was already 2 pi. Yes, you can see a half up cycle, and then the down part of the cycle, and another half of the up cycle at 2 pi. So the period is already set for 2 pi. So I'm going to move it back to 3 pi force. And so, Alan, you were good to call it out. We needed the period checked. We did the vertical shift, the horizontal shift, and the amplitude. And so we can submit this and see how I did. It says I did a good job. Let's try another one. Hopefully it gives us some harder numbers. This one's giving us factored form. Oh, that's interesting. All right, let's do some analysis here. All right, let's write down our facts. Some of the facts are straightforward. We got the amplitude. The amplitude is a half. There's no reflection. Now, what is the period?
Pi.
Correct. 2 pi over b, and b is 2. So when we play around with it, we're going to have to fix the amplitude and the period. Now, what is the horizontal shift or the phase shift?
3 pi.
3 pi force?
Exactly. It is in the factored form. So we are starting on the right at 3 pi fourths. That's because this is in the factored form. It's a little bit easier to find the shift number. And then, of course, there's a vertical shift equals negative
So
2.
with that one, you don't have to do minus C over B.
Correct. If you've got this form here, y equals a secant of bx plus c plus d. Here there is, in this form, bx plus c, we do not have the vertical shift or the phase shift. Phase shift has to be negative c over b. We have to get a formula. Now, it's subtle, it's very easy, and actually Newton, I just wrote like a 2-page report to Newton because they explain this in a way that's a little confusing, so be careful here. They mix up the C number a lot, but I'm going to re-explain it just slightly different. There is another form of this equation that's factored. Y equals a secant of b, but b is factored outside. And then once it's factored outside, I'm going to call it something different. This number, h, is my shift. It's my horizontal shift. Do you see the difference, Kyle, between the green one and the purple one?
Yeah.
So in this factored form, this is h. H equals 3 pi fourths. That is my phase shift. No work. So this format, when it comes, it's a little bit easier in that we don't have to work for phase shift. Okay, so now we just need to go back to Newton and make all these adjustments. So we've already established that we're going to have to do the phase shift. So we're going to have to go over 3/4 pi and down 2. So we'll make sure we got that shift. Actually, I think with Newton, we need to get the period and amplitude right before the shifts. Because once we shifted, then it's hard for me to know if I have the right period. So I think I'm going to do the period and these two first, and then the shift afterwards, because of the way the Newton is pre-programmed and the graph is already there. And so I'll explain what I mean when we get to the back to Newton here. So here comes Newton. Let's see, Google, right there it is. All right, do you guys see Newton?
Yes.
Okay, so we've established that the amplitude was a half. So I set the amplitude. We established that the period is pi. So I think that's the black one. Yeah, the black one is stretching it wider. And so I want a complete cycle in pi. So let's see here. There it is. That's it. Here is here's half of a cycle upwards, then a whole down one, and then half, wait, 3 pi halves. Yeah. So see, that's why.
Doesn't it need to go down more, Professor?
Say again?
Shouldn't it be shifted more?
Well, let's double check. Let me annotate on here real quick so I can see what I've got. It's weird because I'm starting here at this half one, but I know that the period has to equal pi. So this distance, here's a whole one. Here's a whole one. No, let's erase that.
Not right.
Annotation,
It's
undo.
The good way you want make confuse, make one of the asymptotes on the like 0, on the like y-axis, then get the pi, then you can move the way you want.
Okay, so here I have the start of a secant and I have the end of the secant. What is that period in that box?
2 pi.
Yeah. So Kyle, I think you were trying to tell me that I wasn't right yet. I don't have the correct period. So I actually need to squish it smaller. And it's weird for me to see the period. So that's why I didn't want to shift the period, because if I shifted, then the period would even be harder to see. But I can see right now that it's 2 pi and that's too big. Got to make it smaller. It might have even been easier if I'm just thinking in terms of period. To do the asymptotes. Maybe this is what Rahid was trying to say. Look at the asymptotes. Here's the asymptotes from negative pi halves to 3 pi halves. It's still wrong. It's 2 pi. Okay, so just a different way of looking at it. Now that's all helping me see that, oh no, undo. Let me get all that stuff off there. I probably could have left that equals pi. And let's stop the annotations. And that way I can adjust. So shrink it some more. And let's see, what is this period? Pi quarters. Here's pi halves, so here's a pi quarter. Now I'm trying to investigate to make sure, do I have the right period? Here is the start. Here is a down part, and here's the finish, the other half. And that finishes at pi. Okay, so I'm going from 0 to pi. That's really tiny. Can you guys see that?
Yes.
So now I got my period, I got my amplitude. And now we are ready. We can shift this. So for Newton, it's a little better, I think, to work the period and amplitude box first and then do the shifts. Because if I had to shift that, I think I would have been really confused with the period. But let's, we got the period and amplitude. Now let's clear that all out. And let's do the shift. Now we have the horizontal shift. Because it's in factored form, 2 pi halves is 2 pi fourths. 3 pi halves is right there. And then we're going to go down 1, down 2. And I think we got it. I think we got it all covered. We have all the transformations involved here. Let's submit and see how I did. Yep, it liked it. Okay. And there's a little explanation they put in the sine wave there. So that's what your homework is like. If you haven't done 3.2.4, it's going to look like this. And so the test is also going to look like this. You'll have some of these on the test. So I want you
Do
to
one for cosecant.
You want to do one more for cosecant? Is that what you asked me? Rahid, Can you repeat your question?
One for cosecant, not secant, cosecant, please.
Sure. I should probably just share this screen here. Stop share. Share screen to. Okay. Here we go. This one's in factored form. So because it's in factored form, it's a little easier actually because we have the shift number right there. You see that difference with factored form? But to make sure I get myself all clear, don't want to get things too far off, let's make a record of what we know. So cosecant is a flip of sine, and the amplitude of sine is going to equal 1. The period is equal to what? Help me out here. What's the period?
5/4. 4 pi.
4 pi.
Close. Yes, we got to be careful with these fractions. They're crazy. They can mess us up. It's 2 pi divided by 1 over 4. And dividing by, oh no, 1/2. Shoot. Dividing by 1/2 is the same as multiplying by the reciprocal. So it's 2 pi times the reciprocal of 1/2, which is 2 over 1. So we got a period of 4 pi. That's very sloppy. 4 pi. Okay, so we're going to have to adjust the amplitude and the period. Now, we have a phase shift. What's my phase shift number?
Positive pi force.
Right, we're going pi force and we're going to the right. And we have a vertical shift, which equals -1. Now, if this equation was cosecant of 1/2 x minus pi over 8 minus 1, that problem is different. This one we don't have the phase shift. So we're going to have to use -c over b, because the blue equation I wrote is not in its factored form. So this kind is easy. And this blue one is not so easy, not as easy, because we have to find the phase shift by the formula. Okay, but we have everything. We have the 2 shifts, and we have the amplitude and period. So I'm going to go in here and make those adjustments. And so let's do the amplitude and the period first. Okay, so amplitude is already at 1. I don't really have to adjust that. But the period is not right. And more challenging than that, the window doesn't go out to 4 pi. It only goes out to 3 pi. So I have to make sure that when I stretch out Did I get it? Is that the right period?
Yeah.
Yeah, I can't quite see the whole thing because the curve ends at 3 pi on the x-axis. But if we look for other clues, like from here to here, there would be a wave. and it goes from negative 2 pi to positive 2 pi. So that is a total span of a 4 pi cycle, because I have the downward and the upward, and that's a complete one cycle in 4 pi. So I got the amplitude and I got the 4 pi set. Next, I need to erase that stuff because I'm going to be drawing on this or shifting it some more. Okay, so now we need to do our shifts. The vertical shift is down 1, and the horizontal shift is, now here's pi, that's too far. Here's half a pi, here's a quarter of pi. And let's submit it and see how we did. Okay, it likes it. All right, so that's going to test your comprehension of amplitude, period, phase shift, and vertical shift a couple different ways, the paper and pencil graphing and the Newton graphing. But I need to wrap up there on, that's the end of 8.2. And let's see what we can do now with 8.3. So if you have your note packet, find your note packet, find 8.3, and let's take a few notes for a little bit here. All right, why is that so dim? Brightness. All right, that should work. Okay, 8.3. This is a real big one. That is too bright now. Let's see what happens with this. We're going to do inverse trig functions. Now, we've hinted at them before. In chapter, there's the chapter on logs and exponentials. We really got into them. If we have a function, then f negative 1x, we call that the inverse function. It is the function that reverses f.
Professor, we meant to be seeing a whiteboard or something.
Yes, you should be seeing something.
Yeah, there's nothing up.
Oh, thank you for pointing that out. Sometimes I have a button that I didn't click to share. So now I'm sharing it. And so you should be seeing my notes. And we were talking about functions. I was talking about functions and I was talking about the inverse function. So the inverse function is something that reverses or undoes f of x. So that's the focus of the inverse function. It's not the reciprocal. So when we look at sine, that's our function. Today we're going to look at sine inverse. That's our inverse function. And so what sine does is sine takes an angle as its input, and what comes out of it is a ratio. Y over R. Y over R, or we could do opposite over hypotenuse. Those are the different interpretations of the ratio, but it's a ratio that comes out. Now, the inverse is what we're going to study today. It's slightly different. So what this function does, sine inverse, is a reverse of this one. So instead, it's a ratio. That is my input. It's like y over r, or it might be opposite over hypotenuse. We plug that in, and what comes out is the angle. Theta is the answer. So the machine is working backwards. That's what the inverse function is going to do. Now, to some extent, you guys can do this a little bit. If I say sine of 30, that 30 degrees goes into the machine. What comes out of the machine?
One half.
Yeah, 1/2. All right, now what if I'm talking about this problem here? Sine of theta equals 1/2. Well, it's backwards. The ratio is the answer. So what we have to do is think backwards. Sine of something equals 1/2. What's the angle? Say that again. It got cut off.
30?
Did you say 30?
Yeah.
Oh, good. That's right. So we're just thinking backwards. So if we put 1/2 is our ratio, 30 comes out. So that would be like saying the sine inverse of 1/2 equals 30 degrees. So that's what we're studying today, is this inverse trig function. Okay, so I've kind of introduced the concept to you right here already. We'll do a little deeper introduction on sine, cosine, and tangent inverses. We'll talk about domain and range and restrictions of these functions. And then we're going to work with the exact values. And once we understand the exact values and the idea of the inverse, we can solve equations. So Rahid was asking me the other day, how do we solve a cosecant equation? Well, we're going to need these inverses. And once we understand these inverses, we can start solving equations. So we're just going to do baby equations here in 8.3. And then in chapter 9, we'll do advanced equations. So let's do a very fast algebra review of functions and inverses. So when we talk about functions, we have this thing called the vertical line test. And so we can see this is a function, passes, vertical line test. This one is a function. I'm going to say yes, function. So yes, this one is a function, yes. It also passes the vertical line test. Is this one a function, this last one over here? Nope, vertical line test, it fails. Okay, so if it's not a function, then the question of inverse function is a moot point, because if it's not a function, then we don't need to really talk about inverse functions, but the first two are functions. Now the next question is, okay, if they're functions, is there an inverse function? Well, what is an inverse function? An inverse function is a rule that reverses. So it reverses or interchanges the pairs. There's this swapping thing going on. You might remember that from before. So if 2, 7 is a part of F, then F inverse is going to have a swap, 7, 2. If AW is a pair for F, then WA will be the pair for F inverse. Now, an inverse is also a function only when the original function is 1 to 1. How do I know if this original function here is 1 to 1?
Horizontal contest and vertical
Right.
contest.
There is a 1 to 1 function, and it passes the horizontal line test. So we can say, yes, this one is 1 to 1. Horizontal line test, this one fails. The horizontal line test. So this is not 1 to 1. When it's not 1 to 1, it means there is no inverse function. But when it is 1 to 1, an inverse exists. Now we don't know what the equation is, but we know this one has one. Whatever this formula is, there is an inverse function. And so those are some things we learned a long time ago about inverses. If a function passes, if a graph passes the vertical and horizontal line tests, then it's a function and it has an inverse function. Okay, shoot, I didn't get very far. I'm out of time. Just as well because this is kind of very analytical. So we need to kind of digest this very slowly. Okay, so basically your homework is to master 8.2. Finish everything 8.2. Newton 8.2, bookwork 8.2, study really hard. You also have a quiz. Another exact value quiz will be posted soon, but this one will be all the quadrants and in radians. Study hard on all that stuff, you guys. Have a great day, and I'll see you on Wednesday. So long, everybody.
Thanks.
Yeah,
See
you're
ya.
welcome. Good to see you. I'm glad you guys were here. Good job, everybody.
Thank you, Professor.
Bye.